Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're going to chat about point-to-point links, the do's, the don'ts, the why you're following an RFC or why maybe you won't follow an RFC. We can chat through sort of like what makes sense and what doesn't. And I guess we start off with the nitty-gritty down at layer 1 and layer 2 and define a point-to-point link. What is a point-to-point link? And then we can talk a little bit about the first thing that happens, which is, I guess, when an interface comes up, it assigns a link local address, right? So I guess that's a good jumping off point for this one, talking about point-to-points with our point of point-to-points. Yeah, I guess for all collective purposes of what we want to talk about here, it's just it could be a single Ethernet port between two devices. It could be old school serial port of some type, T1, T3, OC3.
You're dating yourself there.
But I think pretty much everything is Ethernet these days. If you're not doing some sort of shared Ethernet segment and you're just plugging one port into another, you're going to have a point-to-point link. Most folks run point-to-point links as a layer 3 peering arrangement of some sort, maybe between two routers or between a router and a switch that has layer 3 capabilities. And that's typically how I see point-to-point links sort of manifest themselves within both data centers and then also for the WAN. Anything you guys wanted to add for that?
Yeah, you can always think about the V4 equivalent in terms of how you address point-to-point links. And from my past experience, that's a lot of like carving up /24s into /30s and deploying 4 addresses when you really only need 2 because the V4 standard forces you to drop 2 of those addresses. And unfortunately, we see that carry over into IPv6 for no reason whatsoever, but we'll get into that, I'm sure. But yeah, if you're used to hacking away on a network, if your experience with point-to-point links, probably, I've got a /30 configured on that, and I've got, 2 endpoints, IPv4/30.
That dated you, Tom, because 31s are the new normal.
I did just date myself. There's been platform support for /31s for a long time, so take my enable password away, somebody, please.
I've seen very few networks provisioned with 31s because a lot of them are legacy. But
yeah,
I've done it. It works.
Nick doesn't work on modern networks. He only works on old stuff.
They don't let me touch actual things anymore. Probably for good reason.
Too funny. Well, yeah. I mean, if you're following that convention, then in the V4 world, if you're doing a /31 or /30, you're probably addressing point-to-point links for the purpose of just getting like something like a router neighbor adjacency up, or you're trying to get traffic from one device to another. It might be a firewall. It might be a router, something of that nature that you're trying to get traffic redirected from one location to the other, and you're using that link to do that specific purpose. So we're really talking about layer 3 here. We're going to ignore layer 2 for the moment, for the purpose of this discussion. And so in V6, we've seen people sort of do V4 thinking. If the case is a /31, they assign it 127, right? So just 1 bit. And then if they're maybe doing 30s, they're thinking about doing 126s for some strange reason, or maybe some sort of variant in between. So we've seen a variety of things depending on what folks want to set up. Maybe they're doing 80s or 120s or something else of a different variation, something other than a 64, I guess is what we should say. But that's sort of the discussion point, is what should you actually assign for those point-to-point links in order for them to function properly for V6? And do we have any strong feelings about that? So if it's not a 127 or it's not a 126, where should it fall? Where should we be setting the prefix length for a particular point-to-point link?
Or should we put anything at all on there? There's another like mind blower for you. Do you put anything at all on there? And why?
Yeah, so I guess we can talk about the link local side first. So every interface is going to provision a link local address, right? So that point-to-point link will automatically have router A and router B will provision link local addresses to use for being able to communicate on that particular link. And those, strangely enough, will default to a /64. And they will be able to communicate with each other. They'll do, all the neighbor discovery things. They'll do all the things you expect, duplicate address detection, everything else, so that they can actually stand up and form an adjacency. For if you're running a base routing protocol like OSPF, it doesn't really even care because it's just going to switch over and use multicast in order to discover each other and actually build a neighbor relationship. So it still needs a link local address in order to build a solicited node multicast address and still be able to do discovery. But the reality is it doesn't need a global unicast address to actually build a neighbor adjacency and actually be able to exchange routes with each other. So I think that's to Nick's point. You can build everything with link local addresses just to be able to get a next hop for an address from one site to the other. And technically you could do this with BGP also, although it's a little strange in terms of configuration. I don't know if I'd necessarily recommend it as a configuration option, but you basically are using the link local addresses to build peers, and then you can encapsulate address family types one into the other. So you could put V4 across a V6 link local address configuration. So it doesn't have a global unicast address, but it still has a link local. And so it's still legitimate in terms of an IP address associated with an interface. Does that sound correct, you guys?
Yeah, sounds spot on. I mean, I think we kind of touched on it in the last podcast about, the routing protocols, the IGPs, and even BGP, where you don't actually need, the GUA address on there because all the communication is going to happen outside of that. And, essentially one of the functions that you get, and the one that is the most visible, I think, is it makes trace routes work, right? It'll show up in the path and you can do your troubleshooting. So it's almost a troubleshooting tool,
right?
More than really anything else.
Yeah, and pulling the lens out a little further, you've got an entirely abstracted layer 3 address that comes up on boot up that, from an operational practice perspective, you probably haven't seamlessly integrated that into how you're looking at the network and how you're troubleshooting it. So, over time, I think maybe the opportunity to use link local in more applications and, especially where you're software defining the network or there's more intent-based networking, there's going to be some sort of overlay that's taking advantage of that underlying link local address configuration that takes the operational choice sort of away from you and takes the troubleshooting responsibility sort of away from the operator. So I wouldn't be surprised to see things head in that direction. But, if I'm on the CLI and I'm hacking away on the network and, configuring a new peering connection or whatever it might be, from an operational perspective, I probably want to go with what I know fairly well. And so, does it make sense then to try to use link local for everything outside of a corner case or, just trying to see what we can get away with, see what we can do? I'd say probably the answer is no.
Yeah, I would agree with you. And this pivots on the whole concept of what everyone likes to talk about with IP unnumbered,
right?
Which just really gets into that concept. And Ivan Pepperniak has a great blog post up on IP Space that came out pretty recently that talks about, is IP unnumbered really unnumbered? And it's really not. He has a pretty funny comment about Linux, about the fact that you can set the same address across multiple interfaces in Linux and allow you to do anything that you want.
Yeah, that's right.
So something that wouldn't necessarily be allowed in other things. It's a good read, so it's worth going and checking out if you get a chance. But yeah, with a few exceptions of maybe like ISIS in certain configurations, there is no real thing as IP unnumbered in the way that conventionally people want to think about it. It is still tied to an IP address of some type in order to be able to determine which interface to forward traffic through, which interface to source something from, things of that nature. And V6 is no different. So link local addresses are definitely something that are going to be there on the point-to-point link, and they're just self-provisioned, so they're super useful for that particular purpose. But I imagine most folks will want to set up some sort of global unicast address directly on the interface itself in order to sort of define what that interface is, especially on routing platforms, to sort of know explicitly what interface IP this is peering with, external resource or, my next hop router that I want to make use of in my WAN. And so I think that's a more common use case scenario than simply just doing everything with link local addresses. I don't know if you guys agree with that, but that's been at least my experience in terms of operational deployment.
Yeah, if I got my consulting hat on, Ed, we've buried the lead here a little bit, as they say. We definitely recommend /64s of global unicast addresses for point-to-point links in an operational setting, and 99.99% of the cases. There's solid reasons for that. We can get into talking a little bit about the fact that when you start attempting to subnet the 64 bits of the interface identifier, that you're into a territory where you can't necessarily guarantee operationally that things are going to work consistently, or there's a risk maybe there. Maybe you haven't thought about TCAM allocation in terms of how much space you have in TCAM to support IPv4 and IPv6 routes and access lists and everything else. And when you start carving up that /64, the interface identifier portion, you're going to chew up more of that TCAM space. So if you haven't considered those from an operational perspective, then you might be introducing a lot more risk into the network configuration by using anything other than a /64 for a point-to-point link.
Yeah, and for those that aren't quite bought into the concept of the /64, we have had discussions in the past of, at least from the address plan perspective, allocate a 64 so that it's dedicated for that point-to-point link. You may decide to set up the point-to-point link with a 127 or 126 if, strangely enough, that's what you decide you need. But you still have the 64 there and available. You're not going to reuse portions of that /64 address space for some other purpose. It's just there for the point-to-point link. And the next point-to-point link gets the next available /64, and you can continue doing that. So that if you change your mind later, not a problem. You just go in and change the prefix length. You can leave the rest of the address alone and it'll still operate and still function. We do have some operational recommendations about what you should consider doing with a 64 to address some shortfalls that might happen for certain platforms or certain, security considerations that you might want to take into account. But I think that's at least my gut feeling is the right way to proceed, is to at least at a bare minimum within your plan allocate /64s for all your point-to-point links. And for that matter, for all your loopbacks too, do 64s just from a planning perspective.
You sort of touched on it a little bit, but I think it might be important to go way, way back to the olden days and talk about why that changed over time. Because like I was saying before we started, when I learned V6, there was no other option. You had to do 64s basically everywhere. And it was, you got a usernet, it's 64. You got a point-to-point link, it's 64. You got a loopback, it's 64. It was the only thing you could configure for a while on many platforms. Then things happened. Maybe we talk about sort of what the history is of why those recommendations came into play, or at least high-level overview of why that changed and how that is an evolving landscape.
Yeah, I think there were a couple security things that sort of cropped up in the midst post this, specifically some ping pong attacks that were of issue that had to get addressed that really were manifestation of just how V6 in the address space actually works. And then secondarily there was actually a flaw in some physical hardware that was made by a manufacturer in terms of dealing with that particular problem. And so the way to address it was to go to a 127 because that limited the scope to just 2 addresses. And so you didn't have to worry about that particular thing. Basically, you're writing an ACL that basically blocks out all other addresses except for the 2 that you have in use, which is no different than what I would recommend you would do anyway. Right? There's no reason to do anything. So just permit for the 2 interfaces that you actually have. You can also turn off, there was also an exploit around neighbor cache getting sort of overflowed because of external devices doing requests for addresses that don't actually appear within that network segment. So if you're asking for an address that is on a point-to-point link that isn't provisioned, it has to burn cycles trying to figure out where that thing is and sending traffic locally to try and determine whether it's actually on link or not. You don't need to do that. So just turn off the neighbor discovery portions because you already know explicitly the 2 interfaces that you're dealing with.
That's right.
There's no need to do neighbor discovery on a point-to-point link, nor on a loopback for that matter. So it's just not a requirement. People don't think of it this way. So it's a strange thing. We just take for granted that neighbor discovery is going to work properly and going to do all the right things. But the reality is that you don't really need neighbor discovery for a point-to-point link when you know explicitly everything that's happening on both sides of the link. So that's sort of the mitigations and sort of corrections you can deal with that. And it's a very straightforward thing. All the major platforms support being able to do this today.
And I think it's also important to say that some of these things are from quite some time ago, right? And so as the hardware evolved, the ability to do things in software, specifically around V6 in this context, has evolved along with it. And so to me, as I look back at it, I look at it as like, this was a bit of a growing pain, as we figured out how things worked and when we deploy them and what things we have to be careful of. And it's just like anything else, it sort of evolves to the level that it needs to be at. And then that will also change over time as well.
Yeah, that's a good way to put it. And there's a couple of very big thumbs on the scale in terms of this question. Of course, one is the RFC related to using /127s on point-to-point links, which, from my perspective, I don't, and maybe Nick, you're certainly more steeped in RFC lore and legend and whatnot, but it does seem a little strange to me that there's an entire RFC dedicated to this one sort of corner case issue, which of course was significantly important at the time when it manifested and caused issues and then resulted in multiple people feeling the need to issue guidance in the form of an RFC. But because that RFC exists, it feels like the shelf life of using a 127 on a point-to-point link or anything other than a /64 is probably a lot longer than it would have been otherwise, based on vendors like sorting out whatever the security issues were from what I understand very quickly. Like it was an issue that cropped up, 2010, 2011 timeframe, was remediated very quickly by the vendors and then stopped being an issue shortly afterwards. But then, of course, many years later, we're still having the discussion. I guess the second thumb on the scale, I would say, is maybe it's in that interval that the carriers, the tier 1 providers, tier 2 providers, started standardizing using 126 or 127 as point-to-point links for peering connections or IP transit connections using V6. And so, of course, if you're upstream, tier 1, if it's, Lumen or whoever else it might be that's like provisioning your link, and they're the ones giving you a /126 or /127 to use, you tell yourself, well, they probably know what they're doing. So, in my own network, I should probably follow some similar pattern. And so I think a combination of those two things causes this question to come up more frequently than it would otherwise. Just to say, just use a /64 or get on with your life. There's no security issues anymore here. There's, from an operations and provisioning perspective, this is the much more clean and efficient way to do things.
I would probably argue back around the service provider side that they have better isolation at scale on their network, and they're probably not propagating that 127 any further past than the first hop.
Yeah.
And so their impact on things like TCAM or routing resources is much better controlled than anything you would probably do in an enterprise to sort of mitigate the impacts of such a long prefix in your TCAM. Because the moment you go from a 64 to anything longer, you will automatically double the amount of TCAM space that you're using, right? So I don't think people really realize how much impact that can have quickly in a larger scale network. In a smaller network, not a big deal. You can propagate all of them and it's not a problem. And you're just using 4 times the amount of what you would use for IPv4, which sounds strange, but that's true. But on a bigger network, that's not insignificant, especially if you have not done summarization in a way that allows you to be more efficient at scale. And that can really bite you and hurt you in the long term.
Yeah, and that's particularly important in environments where the equipment that's deployed is either, data center class equipment that probably doesn't have a lot of TCAM. It's meant for fast switching, minimal routing. And that's really common in smaller deployments too, because frankly, those devices are less expensive.
Yeah, they're financially attractive.
They're financially attractive. And, they may not consider those. I mean, this is the same argument that I've seen made for I need to be able to carry full table BGP, but buying a full box that can handle full table BGP is, 3 times the cost of whatever this thing is I can get on eBay or whatever.
Right. And what people don't realize is if you have to take full tables, that's full tables for every peering link that you're actually peering to. So you're really not doing full tables for one. You're doing like, oh, I got to handle full tables for the 3 peers that I have. And that's why the cost goes up dramatically in terms of performance and capabilities for those platforms once you get higher and higher up in the scaling side.
You're welcome to try to take partial tables on your other connections.
You're gonna take partial tables. You just might not know
You're
it.
gonna take it.
That's right.
Yeah. That's the dirty little secret.
So, I mean, I think the TCAM utilization and capabilities is one of those sort of dark arts of network engineering that until you really, I mean, I didn't learn it until I had to.
Until gear failed?
Honestly, I did not learn that stuff until I had to. And by had to, I mean stuff broke, much earlier in my career, and the type of networks that I typically have worked on, that was long, fat networks with high single stream throughput. We didn't really have the option to buy gear that didn't do anything but those things. But like when, you go into smaller locations and they're like, we need this many ports of gigabit and this many ports of 10 gigabit, but we only have this budget, like the budget drives that, right? And so your only option is this. And it's often overlooked that the TCAM is also going to be, I mean, there's a reason it's less expensive, right?
Yeah, TCAM's the most expensive memory you can put in a device, right? Close to it. And there's a reason it has a limited set of resources within most platforms.
Understanding that and understanding that, like, if I use a 64 everywhere and I just, do these 2 more things, I turn off ND and whatever, that's going to give me significantly longer. It will not use the resources that not doing that will use.
And I guess we're showing a little bit of our age because I think there's some next generation stuff past TCAM now in terms of, next generation ASIC development and everything else. So excuse us if we're missing that part too.
I mean, I like to call it wisdom, not age.
Let's switch gears a little bit. Let's talk a little bit about some of the practical operational stuff because I think that's more useful for the audience. And so let's say you decided to allocate a 64, but for whatever reason, you're going to do a 127 on the interface. I guess my first question is what actual addresses do you actually set up on each side of the interface, convention-wise?
Well, you can't use 1 and 2 as your local and distal endpoints if you use a 127.
Yes. And this is a really important point, everyone. You're going to end up having to do 0 and 1 as a matchup if you want to. It is possible to do A and B. So router A, router B, you could match it up and do A and B. If you have nomenclature conventions of that type, it actually would work out. Obviously, if you changed your 127 back to a 64, it doesn't matter what address you use.
That's right.
They'll both work and you're back in safety zone. But just do realize you're going to have to do a little bit of math. I guess you could do all Fs and then all Fs and an E.
I see A and B quite a bit.
Yeah, I see A and B quite a bit. I do see 0 and 1 used quite a bit also. But I say A and B is probably the most popular that I've seen sort of in use and in practice, just because it does look different than 0 and 1. So it's convention wise within your routing table. It's actually sort of convenient to see an A and a B. And I sort of still recommend that even if you do a 64, you still do A and B and you get the same end result. You just are using a 64, so you're using less TCAM. So that's a win.
Yeah. And another gotcha is if you're using a 0 as an interface identifier that can get concatenated into just looking like a prefix. And then am I looking at an address or am I looking at a prefix?
Or am I looking at a route?
Am I looking at a route? Yeah.
Yeah, and that can get really, really confusing in a hurry. So it's like, oh, why are we pointing this thing to a route?
Yeah.
It doesn't make any sense. Well, no, it's not a route, it's an address. So those are the things that definitely I think are important from an operational basis. Outside of that, I just recommend you set up ACLs and then you set up just clean up ACLs to keep bad things from happening. And there's some examples that are out there for folks to dig around and take a look at. And then just turn off neighbor discovery. There's no reason to have it running. Even with a /127, there's no reason to have it running. So for point-to-point reasons, just go ahead and turn that stuff off. You don't need it. You're putting static manual entries in, or the routing protocol is figuring out where the next stop is anyway. So you don't need it. So you're good to go, especially since you're going to manually assign it. Maybe the exception would be if you're building something like some sort of enterprise class EVPN underlay architecture and it just asks you for a given set of prefixes. You just let it determine what it does. Some of the vendors choose to do 127, some of them choose to do 64, some of them choose to do other size prefixes, and you really don't care at that point because that's their problem.
Yeah, another way to look at that is to maybe suggest ever so gently that if you're using a vendor that's employed a particular standard along these lines that you're going to then use as like sort of guidance, or this is again like looking at the carrier saying, well, the carrier's doing this, they must know what they're doing, even though they have a completely different sort of reason and rationale for why they're deploying it in that way. The same kind of goes for that in those environments where it's much more deterministic and programmatic, and they're seeding these interface configurations with a particular prefix or a particular set of address choices that may or may not be based on anything that would work or would be operationally durable in your network. We see a lot of instances where not only is it not clear what the logic behind why a particular set of prefixes was chosen, but there may even be, addresses being used that aren't even valid addresses in terms of what we would normally see in that environment. So just exercise a lot of caution with making assumptions about, well, if a vendor does it this way, then that's probably how I should do it too.
Right. Some of them may be doing it for convenience of coding reasons, descriptors, lots of other rationale behind why they're doing it the way that they are that have no merit or translation to your operational environment.
And may even violate standards.
Right.
So it's just definitely beware of that possibility.
Yeah. And we've seen several that have used, documentation prefix or have used 6 to 4 address ranges, all sorts of things where you're like, why are you using that? Oh, well, we just thought it was available. It's like, okay, why don't we fix that?
I've seen a network that used 6 bone addresses for all of this in the past.
Yep. So just buyer beware.
Yeah.
A little bit of knowledge will help you to avoid or sort of sidestep these related issues. Not all the vendors are perfect around this, and some of them are reading older documentation or haven't kept up to speed with some of it, or the developer doesn't know any better because they're a software developer. They're not a networking person, and so they just don't know.
Yeah, and maybe it's not impactful right away, and you can always argue, and vendors maybe, this is the tacit argument that, well, it's it's an underlay. Who cares? If
Right.
it's consistent within the underlay, then it doesn't really make a difference. But if for some reason, in a multi-vendor environment, if if that fabric has to be extended out or modified in some way down the road, if you're not operating within the range of the standards, you might find yourself boxed out at that point.
And the vendors have the capability often to do things like correct this over time. So
Yeah, exactly.
they can readdress your underlay and probably not have you know the difference.
Do it the right way.
Yes. And so you don't get that luxury for yourself typically.
Right. Yeah, renumbering everything is a little less trivial.
Right. So I would definitely say those are some of the things that I would take into consideration for point-to-point links. Is there anything else we wanted to talk about, you guys, for point-to-point? I would definitely say it's either link local if you're going to try and do. There is an RFC that talks about using link local for everything sort of across your WAN backbone, things of that nature. Fun read. I don't know if I'd actually operationalize that or not. I think I have a tendency to be more in the global unicast family camp to do everything, but link locals are still useful because it allows you to do hop by hop across your network. So you can still go in and administer things, which is sort of cool. I would avoid ULA for any of these purposes. I don't know, Nick, if you have any comments or thoughts on that one, but
I mean, I try to avoid ULA unless there's an absolutely fantastic reason to use it, which there are very few of those. So,
Misguided mandates might be the only ones.
or just misunderstanding of how everything works.
Right.
I tend to sit in the GUA camp. I've done some testing and some stuff with OSPF, where it's just link local.
Mhm.
Totally works. Don't know that I want to run a big network that way, but I'm sure you probably could. It breaks trace routes, which is irritating for users. But of course, if you want to get technical, like I've seen networks that use RFC 1918 space for point to points. And so trace route works outbound, not inbound, and,
Mhm.
questionable utility, I guess. So
Yep.
Yeah.
I like GUA. It's easy. You can fit it in with the rest of your address plan. You track it in the same way you track everything else. 64s make everything easy.
Yeah, and as long as you're doing the right thing from an address space perspective of building like an infrastructure block that actually contains those particular, address ranges, then you can write all the ACLs in the world to protect those particular infrastructure ranges that other folks shouldn't be exploiting or doing bad things to. So you won't starve for resources. So if you need to do some sort of control plane policing, or if you need to do traffic engineering or anything else of that type, all of it's still applicable, and you would just apply it for those particular interfaces and address
Yeah.
ranges, prefix ranges, and you're good to go. That's in a bucket, point to points. I guess we'll have to cover loopbacks at some point. I don't consider this part of the basic series just because this is probably more of an operational issue than just a fundamental of the protocol. I don't know if you guys feel the same way, but it's much more of an operations thing, right?
Yeah, and in some ways it is a fundamental because it's a question that I get asked a lot, but in other ways it's very much not. It tends to trend into like religious territory. Like some people have very strong opinions on point-to-point addressing for V6 only. For V4, it's you do 30s or you do 31s. I mean, I don't know anybody that's doing /24s for IPv4 point-to-point addressing. I'm sure that exists, RFC 1918 space, just 24s everywhere, but this was a little bit different. I like GUAs. It's easy.
Yep. Yeah, I agree. I think in some cases, for operational simplicity, folks might try and match up what they're doing from a V4 perspective, because that's the go-to. Oh, well, we want to match everything in V4 that we're doing with V6. But I think in this case, it might be a mistake.
Yeah.
Just wanted to call it out.
I'll once again say what you have said in the past, Ed. Like, it may seem desirable to try to match what you've done in V4, but you can also use this as an opportunity to fix all the things you don't like about how you had to do it in V4.
Yeah, exactly.
Consider that.
Thank you for attributing that to me. I don't recall ever saying that.
I thought I heard you say, maybe it was Tom. I can't remember. I did not make it up. I'll happily take full credit for it.
There we go. We now quote Nick. Awesome. All right. Well, there you go. Point to points. Write us a note and let us know in Flame War all the things that we have said that are incorrect.
Oh, no.
Take care, all. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.